One of the things that I mentioned in class the first day is I want you to take a look at the MIT Open Courseware, and if we click on this link right here, it will bring us to an MIT website. I want you to look at, if you haven't already, the first couple of lectures. There's a couple of good tips and tricks in here about working with the command line, or the switch over to MATLAB. We look at our command window here, so there's some good tips and tricks for navigating through there, and the command prompt as well, and we'll show you a little bit into, if you go into the third video, what we'll be talking about today, which is saving scripts, writing programs, saving them as a .m file, which is just a text file that you can actually open up in any text editor. But before we move on to looking at script files and how we actually save programs, there's a couple of items that we didn't get to in class in sections 1.1 through 1.7. So a couple of commands. I'm going to type CLC in the command window to clear my command window. CLC for clear command, or clear command window. A couple of the functions that we didn't look at, for example, if the ceiling function, if I type in CEIL and then say pi, for example, which of course is 3.14159 ... What ceiling will do is we'll round up towards infinity to the nearest whole number. So if I typed in, for example, ceiling of minus pi, take a second, see if you can figure out what that would round to. So we're looking at negative 3.14. It's going to round up towards infinity, towards positive infinity. So it'll round it up to negative 3. So the opposite of that command would be the floor. If I do floor of pi, it will round down towards minus infinity. So if I hit the up arrow and change this ceiling minus pi to floor, take a second, figure out what that's going to round to. So that would round to negative 4. Okay, so those are pretty straightforward. And as we know, we can assign these to variables. So for example, I can go back to that last one where the answer came out to negative 4, and I can assign that to a variable, say x equals that, and it will tell me that x equals 4. If I put a semicolon, we'll see a couple of more examples of this in a minute. If I put a semicolon at the end of the command in the command window, it will still assign the output of this function, floor minus pi, to that variable x, but it just won't display it in my command window. So I'll clear the screen again, so back up at the top. So if you're following along in the textbook, which I highly recommend you do, I'm looking at page 18 right now. So for example, and you should walk through all of these. If you're brand new to MATLAB or brand new to programming, you should walk through all of these example ones in the text and make sure that you understand everything that it's doing. So if I type into the command window a equals 12 and b equals 4, then with a semicolon. So I'm typing in two separate commands here with a comma in between, or two variable assignments rather. And when I hit enter on that, you'll notice that the a equals 12, because it did not have a semicolon after it, actually displayed in the command window. So if I, for example, go back and put a semicolon after both of those commands, then neither one of them will display. But if you can see my command history down here, as we looked at, I can copy and paste these, for example, or I can paste and enter, or I can come over here to my command history. If you don't have this turned on, remember, I just pretty much leave all of these on in the default layout. If you've changed your layout since you opened MATLAB, click the layout up here at top. You can just barely see it off the top of my screen, and I recommend just leaving it on default layout. If you want, you can turn everything off but the command window while we're doing that, but it is nice to have the workspace. Remember, that's where your variables and the assignments, assigned values, are displayed up here. And so to see those, if you just have the command window, you can type in who, which will tell you what variables are currently assigned values, or if I type in WHO with an S at the end, it will give me some more detail. The size, this is a 1 by 1. They're all 1 by 1. If they were vectors or arrays, it would tell you the size and shape of them. It tells you how many bytes that memory location takes up, and that its precision is double, which you can look back about 10 or so pages, and you can see what those different classifications are. We'll go into that more as we go through the course. A couple of more things to note still on page 18, rules about variable names. They can be very long, up to 63 characters. You can use things like underscore and dashes in your variable names, so you could have a underscore double or something like that. Can contain letters, digits, and the underscore. You cannot put any other punctuation in it, like periods and commas and semicolons, because as we've already seen, those are already used in commands. For example, you've probably also seen by now the %. It will turn your text green, and this is a comment. It doesn't do anything. We're going to use comments extensively when we write our MATLAB code to describe what the variables are and what the functions in the program are doing as we're writing them. So it is case sensitive, so x equals 4 with a capital X is not the same as x equals 3, for example. Those are two different variables. Capital X and lowercase x are two different variables. And I did mention on Monday, avoid using the name of built-in functions. Don't call your variable COS or EXP for cosine or exponent. And at the top of the next page, it has a list of 20 keywords that are also reserved for MATLAB for various purposes that you cannot use as variable names. Things like brace, case, break, case, catch, etc. Okay. So let's move on to section 1.8 regarding script files. So as I mentioned, a script file is a sequence of MATLAB commands. You save it, can also be called a program. So the terminology that we use is you run a script file, or you execute a script file, and then MATLAB will execute all the commands in the order that they're written, like most programming languages. And when a script file has a command that generates an output, for example, the assignment of a value to a variable, like we're doing. Let me go back here and clear my screen again, clear my command window rather. If you have, for example, x equals 4 in a MATLAB program or a script file, if you do not have the semicolon in there, it will actually still display it in the command window, just as if you had typed it in a command window. So let's see how we create a script file. So what we're going to do is we're going to, you can see, we can see on the top left, the new button, the big yellow plus sign up there. You can click the drop down where it says new and start a new script file there, or directly from the command window, you can just hit Control N and it will open. In this case, I've got this docked over here on the right hand side, so you can resize these windows as need be, or you can turn off your command window if you didn't need it anymore. You can turn off your current folder and the details. This is down here on the bottom left. I have the details of the file if I had one open. Okay. Also notice when you open up the editor window over here, this is where we're editing our script file. It opened up a couple of new tabs up here on the top for us. It switches you over, it opens up an editor tab. I'm not sure if you can see that one, but you can see it on your screen. It opens up an editor tab up here where we have a bunch of different commands that we can use in the process of writing our MATLAB code. For example, I can click the run button once I have some commands on here. So from here, it'll ask me to save it before it does that. Or I can run a particular selection. If I select and highlight some text in my script file, my M file over here, I can run a particular set of commands by selecting them and then clicking Run Selection. And there's a couple of options under the Run. If you hit the drop down up here, pause on errors, pause on warnings, things of that nature that we'll look into in more depth as we proceed. Another thing that I did mention in class on our first day is we have our current folder shown up here, and you can turn this bar on and off. I recommend just keeping it on. So you'll see in the MIT video as well how we either need to be in, when I save this file and I try to run it, it either needs to be in the current folder or we need to have that. We'll just leave our programs in this main MATLAB directory for now, But if you've watched video 3 on the MIT lectures yet, if we type in the command path, it'll show us. Let me go back to my layout, command window only. So I can see the path are all of the folders that if you type in to run a program, for example, you either need to be, the program itself either needs to be in the current directory or it needs to be in the path. And like I said, we'll just leave it in the main MATLAB directory for now. We don't have to be concerned about that, but you can create subfolders in here and then add them to your path so that you can run a program without it having to be your current directory. So we're not going to mess with that right now, but when you watch video 3 in the MATLAB, we'll get you can see some more details on how we would do that if you wanted to. We'll walk through a quick example of how to enter an algebraic expression into MATLAB, save it as a script file, and then run it. So here's what we're going to enter right here. I'm trying to make this bigger, but it won't let me in this program. Okay, so I'm just going to pull this over here. So I'm going to take this expression right here, and I'm going to create a couple of variables. I'm going to create one for the numerator, the square root of 4 minus 2. I'll create another one for the denominator, and then I will write on here, making sure that we use our order of operations, so we put parentheses where we need them. So if we look at what my program is here, so I'm annotating it up top, put my name, ENG105. So remember, the % means a comment, so these show up in green. And so I just put my name, ENG105, and I say this is an algebra example, how to write and save a script file is what we're talking about. So if I bring back my equation here that I'm trying to put in, it looks like I missed the numerator's got the 3 in it right here, so I didn't miss it. Okay. So I'm going to write a variable called numerator, and I'm going to set it equal to 3 times the square root of 4 minus 2. If we look at this right off the bat, we can see the numerator is going to evaluate to 0. The square root of 4 right here minus 2 is going to evaluate to 0. So when I run this script file, I'm going to get 0 divided by something, and then it's going to be minus 5. So we can, by inspections, see that our answer should be minus 5. Which I believe you might even be able to see on the bottom of the screen already. So let's minimize this guy. So I've got my numerator equals, and notice I do not have the semicolons at the ends of these lines. So when I run this script file, which you can see I already have down here, when I run this script file by clicking the run command up here, I go back to my command window. Oops, I'm capitalized. CLC. So clear my command window. And the first time, if I have this right here and I try to run it before I save it, it's going to give me a warning that I need to save it. So all I did was I hit this save right here, and if I do save as, you can see what it would look like the first time. It's going to bring me into my active folder here in my path, and then I just named it algebra_example. It's saving it as a MATLAB code file, which is a .m script file. I'm going to say no to replace it, so go ahead and save it, and then now I can run the file here, and you can see on my command window it executes the script and it gives me my output. Numerator equals 0, denominator equals this, and when I subtract 5 from 0 divided by this, so it's just 0 minus 5, and the total is 5. So for example, if I went back and I put semicolons at the end of these 2 lines right here, and I resave my file, go back and clear my command window, and I can now run this file. I'm now down in the command window. If I type in algebra example, because this program is in my active directory here, I can just type in algebra example here in the command window. Instead of opening up the file and clicking run on it, I can execute a MATLAB program, a script file, by just typing the name of the command. If it needed inputs to run this code, then I would type in algebra example and then some inputs, the same way the sine and cosine function work. Okay, and as I mentioned, if I type in help algebra Think for a second what might happen. What it's going to do is give me this text that I have here at the top, my comments that I put in the beginning of the program. So when you have something that someone else is going to look at, that's where you would essentially put your information that's going to tell the person how the program runs, what it's doing, what inputs, if any, it requires. And you would just put that as comments at the beginning of your script file, and then those would display when someone types in help and then the name of your program.